The more you can talk to her, the better, right?
Yeah,
Yes, yes. All right.
But I also need to practice.
Your English is great. All right, let's continue. So we have one question to do from homework. Right. Long day?
Yeah.
How many classes?
How many breaks would be easier?
Okay, true. How many breaks?
None.
Good, yeah, that is easier to understand. Right. Mechanics, and we were looking at Newton, weight, wasn't it?
Yeah.
And there was one question to do from the homework. So we'll have a look at that first, and then we'll go on to the next topic. Okay, how did you get on with the last one here? Number 4. Anyone feel like it was successful? It is, yeah. Okay, let's have a look at number 4. So we have two beakers, I think, and then so one of them is put into water and one of them is put into empty beaker, and it's 1 meter tall, both of them, and this falls and of course hits the bottom, and this one falls and hits the bottom, but this one takes 10% longer to hit the ground than this one. It takes 10% longer. So the first thing I want to do is work out the time. U-V-A-T-S. Here. The U? 0. V? Don't know. A? 9.81. T is what we want. And S? Minus 1 then, yeah. If you want to use plus and plus, that's fine. And which formula will give me the T here? No. B squared? No. B equals? That's the one, yes. S equals U T plus a half A T squared. That's gone. So we have 2 over 9.81 square root. Yes?
Minus 1 minus. Sorry, my bad, nothing happened.
0.45 seconds is the time. This one takes 10% longer. So I should add on 10%. And here I'll get the T is 0.497. How do you add on 10% quickly? Anybody know?
You add 0.045.
Yeah, just divide it by 10 and add it on, or multiply by 1.1 or whatever. You could just divide by 10 and add it on. That would do. Okay, in the second half, what's the U? Still 0, isn't it? The V? Don't know. We don't know. We don't know the A here, huh? It's different. But the S we do know is minus 1. And I want to know the A this time, so what formula should I use now?
V equals U. No.
V equals U.
You have the T, you have the U.
S is equal to U plus V.
S equals U T plus a half a t squared. Isn't that S equals ut plus a half a t squared?
Yeah. Yeah?
Yes. So I can get the a from this. Minus 1 times 2 divided by 0.4975. So the a works out to be minus 8.097 meters per second squared, not 9.81. It's less because of a drag force, and that's what we're going to work out next. So now, yep.
Will the acceleration be constant?
In our problem or in real life?
Very nice.
In real life, no.
Or isn't it too short to reach terminal velocity?
This, I'm not sure if it will reach terminal velocity by the end here.
So it is constant.
The acceleration,
Yeah.
we're going to take it as a constant, but I have a feeling that at the beginning it will be bigger, and then it will decrease until eventually reaching 0, which is terminal velocity. Yeah. Okay, so let's calculate the force. F equals ma. What did I say the mass was? 10 grams, wasn't it?
Yeah.
Yeah, so if I just multiply this by 0.010, the force is minus 0.08097 newtons. So in other words, down 0.08097 newtons down. What forces are acting on this ball? There's two forces,
Acceleration and drag.
weight and drag. And which one is bigger? The weight is bigger, yeah. In fact, you know that the weight minus the drag is the total force down, and the total force down is 0.08097. So the drag is the weight minus 0.08097. The weight, what's the formula? mg. Do we know the m?
Yes.
Do we know the g? Yes, so we'll just hit them all in. 0.010 times 9.81 minus 0.08097. So the drag force is a small 0.0171 newtons. Yeah? 17.1 millinewtons. Okay. So this one was hard, but not super hard. You just have to break it down into 3 parts. Part 1, or maybe more than 3, 4 parts. Part 1, get the time. Part 2, add 10% to the time. Part 3 is get the acceleration and the force. You know, they kind of go together. And then part 4 is to get the drag force. Okay, if you need to write that down, which you probably do, I'll just box it off. So that was part 1, that was part 2. This one here was part 3, and then this part here was part 4 then. Okay, write that down, and then when you have it, we'll start the next lesson. Tired? Wish you weren't in the last class? Into which part? On that boat, we'll die. Fresh air. Hey! English.
He's worried about the safety of my head.
Don't be. Don't be. Okay. Are we writing this down? 1 more minute. Now, Fuang, I don't know if I want you sitting by yourself because you're going to have to learn these new people's names. So I'm one empty seat there. Omar's a nice student. Ah, you're okay.
Okay, but
I know, you stay away from that guy. See him there? He's big trouble. Yeah.
Where can I sit?
There's one spot there. Now how are you going to get in there? There. Now you're trapped. You can't escape. Okay. Okay, do we have this? Yep. We start the next lesson? Oh, come on. Oh. Huh? Is he, what?
I thought the one you writing book. Writing book inside the paper.
Yeah.
It's saving the paper.
Exactly.
Yeah.
Difficult when you study at home, but all these papers.
Different strokes for different folks.
That's what I thought.
Yeah.
Do you only write on
Maybe I'll
one?
start doing
You waste paper. Alright. Can I close this now? Yes? Okay, well